Hi, welcome back. I'm Professor Ronald Vincent M. Santiago, and today we'll be discussing Module 21, Case 2, Faults on Power Systems at No Load. Let us discuss first the unsymmetrical faults on power systems. A power system generally consists of generators, transformers, and transmission line connected together. The calculation of the fault current for a system operating at no load is done by using the equations as derived for the case of unloaded generator. But the impedance, say 1, say 2, and say 0 now have the following meanings. Say 1 is the total impedance of the positive sequence network measured between the fault point and the reference bus. Say 2, the total impedance of the negative sequence network measured between the fault point and the reference bus. And Z0, the total impedance of the zero sequence network measured between the faulted point and the reference bus. Now, let us consider some important points for positive, negative, and zero sequence networks. First, the synchronous generator has negative sequence impedance slightly less than its positive sequence value. Second, however, transmission lines and transformers have the same value of impedance to positive and negative sequence currents. Third, any impedances connected between the neutral point and earth are not shown in the positive and negative sequence networks as the loads are considered balanced and hence all the neutral points must be at the same potential. Since all the neutral points in a symmetrical three-phase system are at the same potential, when balanced three-phase currents were flowing, thus all neutral points must be the same for either positive or negative sequence currents. Fourth, the zero sequence impedance is about 10 to 25% of its positive sequence impedance. The zero sequence impedance of the transmission line is about 2 to 3.5 times as large as positive sequence impedance. And fifth, for the transformer, the positive, negative, and zero series impedance are all equal regardless of the type of transformers. Calculation of fault currents on power systems. First, convert all old per unit and actual reactances to its corresponding new reactance using the specified base of the system. Second, determine the positive, negative, and zero sequence networks of the power system between the fault point and the reference bus. The networks must be simplified by its corresponding Thevenin's equivalent circuit. And third, after measuring the values of the impedances, say 1, say 2, and say 0, of the system between the reference bus and the fault point in the positive, negative, and zero sequence diagram, respectively, the symmetrical components of currents can be easily calculated for the different types of fault by using the following equations derived for the case of the isolated generator or case 1. So that ends our Module 21. See you in our next module.